Welcome friends. In this tutorial, we will learn about insertion and deletion in AVL trees. Now insertion. We insert a node using a BST insertion algorithm. Then we rebalance the tree if an imbalance occurs. An imbalance occurs if a node's balance factor changes from -1 to -2 or from +1 to +2. Balance factor of a tree can be found by making a difference of height of left subtree and the height of right subtree from the current node. Rebalancing is done at the deepest or lowest unbalanced ancestor of the inserted node. There are three insertion cases. Number 1, insertion that does not cause an imbalance. Number 2, same side insertion that causes an imbalance, that is left-left or right-right insertion, requires a single rotation to rebalance. Number 3, opposite side insertion that causes an imbalance, that is left-right or right-left insertion. It requires a double rotation to rebalance. Insertion case 1. Consider this tree. Here, on inserting key element 14, there is no imbalance in the tree. Insertion case 2. Case 2a, the lowest node with a balance factor of -2 had a taller left subtree and the insertion was on the left subtree of its left child. It requires single rotation to rebalance. Consider this tree. On inserting key element 3, we have to perform a single right rotation to rebalance. So on right rotation with node 10 as pivot, this will be the tree which we will obtain. Insertion case 2b, the lowest node with a balance factor of +2 had a taller right subtree and the insertion was on the right subtree of its right child. It requires single left rotation to rebalance. Consider this tree. Here, on inserting the node 45, we will have to perform left rotation with the node 30 as the pivot. So we will obtain a balanced tree as shown here. Case 3. Case 3a, the lowest node with a balance factor of -2 had a taller left subtree and the insertion was on the right subtree of its left child. It requires a double left-right rotation to rebalance. On inserting 7, we will have to perform a left rotation with node 5 as pivot and right rotation with node 10 as the pivot to obtain a balanced AVL tree. Case 3b, the lowest node with a balance factor of +2 had a taller right subtree and the insertion was on the left subtree of its right child. It requires a double right-left rotation to rebalance. On inserting 15, we have to perform a right rotation with node 16 as the pivot and a left rotation with node 9 as the pivot to obtain a balanced AVL tree. This is a short summary of AVL rotation, which is the first one is single right rotation, second one is double left right rotation, the third one is single left rotation, and the fourth one is double right left rotation. Now deletion. Delete a node by a BST deletion by copying algorithm. Rebalance the tree if an imbalance occurs. There are three deletion cases. Number 1, deletion that does not cause an imbalance. Number 2, deletion that requires a single rotation to rebalance. Number 3, deletion that requires 2 or more rotations to rebalance. Deletion case 1 example. Here we are deleting 14 and so there is no imbalance, so we will not do any rotations. Case 2, here on deleting 40 the tree becomes imbalanced, so we have to perform a right rotation with node 35 as the pivot. Now here we are deleting 32, so we have to perform left rotation with node 44 as the pivot. Case 3. On deleting 40, we have to perform right rotation with node 35 as the pivot and right rotation with node 30 as the pivot to obtain a balanced AVL tree. This was all about AVL trees. Thank you for watching the tutorial.